We're back from the break and ready to keep going. Please welcome Parth Menon, software engineer at Meta. He'll share how experimentation drives innovation and smarter decision making in big tech, straight from real world experience.
Yeah, I'll just start by sharing my screen. Yeah, hopefully you can see my screen. Hi everyone, I'm Parth and I'm a senior software engineer at Meta. I've been working in the industry for almost 10 years, and right now I'm working as an Android engineer in the images and mobile storage for Meta's mobile apps. At Meta, we focus on impact, and impact is outcome based, not output based. To showcase impact, we need to prove how we work and how that work has real world implications. The proof we often show is movement in metrics that the company cares about by running experiments. Now, what is experimentation? Experimentation is a type of A B testing in mobile apps where the same version of the app is used, but different app elements or features are presented to users based on configuration values. These configuration values return different settings for each user, allowing for evaluation of their impact on user behavior and app performance. Now, experimentation is essential because it shifts the focus from output oriented work to outcome oriented results. It validates the success of projects and measures and provides measurable impact that aligns directly with the goals of your team, organization, or company. It enables data driven decision making and fosters innovations, reduces wasted engineering, and improves user experiences, ensuring every initiative delivers meaningful value. Now, experimentation differs from traditional A B testing, where multiple versions of the same app are built and distributed separately to different user groups. This was the default approach in Google Play Store and other Play Stores because it was easier to do. You just built a separate version of each app and separate it out by users. But there are a couple of challenges in this way. First, the users are stuck with one version of the app until they manually update it. Multiple experiments can interfere with each other, and there's a limit to how many versions can be tested simultaneously, leading to a whole backlog of experiments. In contrast, experimentation uses a single app version with dynamic configurations, avoiding all of these issues and allowing for more flexible and efficient testing. How does it work? So, experimentation works by embedding two or more flows in the same app code, controlled by a remote configuration. This configuration determines which code path each user follows. The simplest setup includes a control group, which is the existing code flow, and a test group, which is the experimental code flow. We have a hypothesis that the test group will perform better than the control group or move the metrics how we want it to move. And that is what we are validating by running the experiment. This approach allows for dynamic testing without requiring app updates because the remote config is what changes the app code flow. The app can be released with both code flows and have enough user adoption before running our experiments. Now, the fact that we have user adoption means we can run multiple experiments at the same time. We can also turn off and on experiments based on the success or failure of these experiments. And we know once we know if a particular code path is better, we can just shift the entire user base to the better code path. Now, so that is how we can change the flow based on results. Now, how do we set up an experiment? The first part of setup includes creating a gatekeeper. The process begins by selecting a universe of users, which is all the users we have, through a gatekeeper mechanism. The gatekeeper filters based on specific criteria, such as app version, geographical area, device type, and other relevant parameters. At Meta, we usually experiment first on employees before releasing anything to the public so that we can catch all the major issues before it's out there for everyone else to see. Our usable set of users consists of those who pass the gatekeeper criteria. Initially, this could be 50% of the total users. Now, this 50% becomes 100% of our experimentation universe. Over time, as the people update the app or users meet the gatekeeper requirements, the universe may grow or shrink. Within this universe, multiple experiments can be run simultaneously by allocating different percentages of users to each experiment. For example, experiment 1, in this case, uses 30% of our universe. Experiment 2 is 20%. Experiment 3 could be another 10%, and so on. Overall, the total universe is 100% of all of our users who pass the gatekeeper. Once an experiment is allocated, the users within the experiment are further split into two groups. In our example, we can have multiple obviously. In our example, we have in experiment 1, which is 30%, we have two groups. One is control group and second is the test group. So 15% of total users experience the control group, which is the normal flow, and the other 15% experience the test flow or the experimental group. This ensures that a balanced comparison is done to evaluate the impact of the changes effectively. Metrics. Metrics prove the outcomes we want from experiments. At Meta, engineers create various metrics including network bandwidth usage, CPU utilization, image video load latency, app startup delay, etc. And all of these metrics are already created by engineers, which can be used going forward for all other experiments by other engineers. Metrics are measured using event logs sent to our server. The server receives these logs, samples them, and then determines the mean and confidence level for each group, allowing us to compare performance effectively. So events get sent to server, events get sampled because we have like 2 billion users. Obviously, we can't calculate so much. So we usually calculate 1 in 10,000, and then we compare it with the baseline. This is an example, a real world example of an experiment we ran a while back. We use these metrics to create a time series chart that tracks changes from the baseline provided by the control group. The delta, or the difference between control and test, combined with the confidence interval, visually represents the success or failure of our hypothesis. And that helps us determine the experiment's impact over time. So this image in the slide is from an experiment I ran. The length of each bar represents the confidence interval of the difference between the test and control groups. The longer the bar, the less confidence that the particular experiment is actually moving the metric we want, because the points are being spread across. As the bar gets smaller over time, this validates that the test group is definitely performing better than the control group. And we have on average about 1.5% reduction in the metric we are tracking. In this case, I was tracking CPU utilization. So the experiment shows success over a week's time with reduced CPU utilization of 1.5%, which is a valid and concrete proof of the success of my project. So what are the benefits of experimentation? First one is direct metric impact. It validates the team goals through measurable outcomes without any extra data engineering effort. It helps us validate hypotheses faster, ensuring that the team is moving in the right direction and we are thinking of solving the right problems. Experimentation allows for fast failure, so we avoid wasting engineering resources. Imagine spending like 6 months on a project, hoping we would get a great success, and then nothing happens after the release. By running a quick experiment to validate the hypothesis, we can ensure that the project is impactful on release, and then we know for sure in 6 months we will move the metric we want, or we will have the release that we want. By having multiple test groups and multiple configurations, we can identify the best solution through the multivariate testing. So if we have 4 experiments and they're all running different configurations, we know for sure we can find the best one by comparing each of these different values. Now let's see how you can run your own experiments. So the rest of this presentation will be me going through the Firebase experimentation framework and how you can set it up yourselves. Meta's internal experimentation framework is called Quick Experiments, is completely in-house, and there's no external options for developers to try it out. But Firebase by Google provides a very similar framework that can be used by app developers to run experiments. You can go to the link in the slide, or you can search for Firebase experiments, Firebase A/B testing, and you'll reach the Firebase testing homepage, which looks like this. To get started, we need to create a project. So in this case, I'm going to call it experimentation test. We must enable Google Analytics. I mentioned earlier that we use event logs that are sent to our servers, which does all of the calculation that we want to compare between the multiple groups. So in the case of Google Firebase, it's Google Analytics. Now, Google Analytics sends those event logs to Google, and they do all of the calculation, all of the aggregation, and gives us the p-value and confidence level. So we don't need to do it ourselves. Now we have a Firebase project created. We can start our experimentation setup. I'm going to focus on the Android side of things, but it's very similar, if not the same on iOS, just slight differences in dependencies and usage in the code. So for the first thing we need is an Android app. I created an Android app called Experimentation Test, and I uploaded it to GitHub. You can go to the link here and basically download the code base yourself and run it, and then you'll see the same results as you're seeing in the slides. And I'm going through the same app in this demo. I'll keep this for a second more just in case someone wants to try it out. Okay, once we have our app, we need to register it to our Firebase project. This involves giving it the same name and package name as our Android app and uploading a signature. If you hover over this particular tooltip, it'll show you how to get the signature. A signature is a key store that developers use to sign the application before it is published to Google Play Store or other app stores. It ties your specific app to the developer, as each key store is unique. It's it's basically proof that you own the app. Now you provide the signature from the key store as a way to authenticate your app with the Firebase project. Once that's done, Firebase provides a JSON file that you place within your project that contains the authentication key to access Firebase APIs. Again, I have done this in the experimentation test app that I've published. Obviously, I removed the authentication key, so you will have to create your own project and just copy paste the values in the key. The setup tutorial is pretty good. It's well documented and provides all the dependencies to be added to your app for Firebase to work. But I've done all of this in the app again. We discussed before that the experimentation flow is controlled using a remote configuration. In Firebase, this is called remote config. So if you see on top here, I'm not sure if the cursor is shown, but it basically says firebase google.com/doc/remote config. Unfortunately, the initial tutorial does not go through this portion of setup. So that's why I've linked it here. We need to set up our remote config before we can add it to our code base and run experiments. Again, if you download the GitHub code base that I linked before, all of this is already added and you can just modify the app to get started. So the remote config tab is on the left side. And here I created a config called button color with the default value blue. The configuration is very simple. It's a simple dialog and I'm not going to go through it here because it just has like 3 fields, the name and the value. Once we have the config, we need to tell our app that this config exists. And we do that by downloading an XML file with the default values. In this case, button color blue is the default value. If you have multiple configs, all of them will be added to this XML file. We place this XML file within our code base here under XML tab, and we reference it in our code as the default. So I'm going to walk through some parts of the code so it's easy to understand. First, I created a remote config instance. Again, I'm not sure if the cursor is being shown, but I hope it is. So first we create a remote config instance and set the minimum interval between fetches to 3600 seconds. This is to ensure that we have the latest value of the config from our servers. Right now, the default value on the code is blue and on our servers is blue, but we can change it on the server to red and it would fetch the latest one every 3600 seconds and to ensure that the latest value is always present in our app. Now, once I've created the instances within onCreate, which is what is first called when a page is displayed, I set the config settings, which is our minimum fetch time, and the defaults to be loaded from the XML file. Then I run remote config.fetch and activate. The fetch and activate will set the default values of our remote config and then try to fetch the values from server. If we change our remote config value on the Firebase console to red, the fetch and activate will override the default blue to red. So every user of our app will now use button color red instead of blue, even though the default in the code is blue. This is the feature that's provided by remote configs. Scrolling down a bit more, you can see that I passed the value of button color, and based on the color, it either displays a red button or a blue button. As the default is set to blue and the console value is also blue, when we run the app, we see a blue button. Now let's get back to and start our experiment, right? So now we have blue button. Back in the Firebase console, we've set up our remote config both on console and we've set it up in our app. Now we can start our experiment. So back in the Firebase console, we have an option to start A/B test directly from the remote config. It's this experimentation beaker kind of symbol. We create an experiment directly from the config. The name is auto-generated, but obviously you can change it. I recommend always putting a version for your experiment because most times you will always find you will need to create multiple iterations of an experiment just to get the final result you want. So usually you start experiment button color v1, v2, and so on. We set the targeting. This is where we select our app and the universe of users. In this experiment, I've selected 20%, which means the rest 80% is available for running more experiments. You can additionally set an activation event. So only users who have this event will be part of this experiment. In this case, I don't have an activation event because our app is very basic. So I will skip it. The activation events can be general events such as first app start or session view or something like that. All of these events are generated by Google, or you can create your own event. And if you send that event, that user will be part of this universe. Now you select your metrics. You can select multiple metrics. There are default metrics available in Firebase, such as session start, first app launch, purchase successful. Purchase successful is used if you are selling apps in your selling products in your app, like in-app purchases, or you can create your own event as a metric. I'm selecting session start here because it's already there and I don't have a lot of extra events in my app. Now, finally, we select our groups. So the baseline is our control group. By default, we have button color value blue, which is auto-generated because it's set as default. And there's variant 1 or V1 with button color red. So that's what we are creating as our test flow. So in this experiment, I'm considering that a red button has higher probability of being clicked than a blue button, which is what we have to validate. You can add more variants if you want, like green or something else to test, or you can add different remote configs alongside these parameters if you want to test multiple multi-variable configurations. That way you can run experiments of different variants with different configurations and find the best one that works. The variant weights denote how many users go through each app. Ideally, to prevent mismatch groups or doing the calculations yourself, it's best to split evenly between groups. I don't really know if there's any reason you would not split evenly unless you feel like the test group has higher chance of failure, especially crashes. So you want less users to go through your test group. So now we've set up our experiment. The experiment is still in draft stage. It isn't running yet. You just set it up. Before we release it into the wild, we need to test it and we need to ensure it works and if there are any bugs. So to get started with that, we click this three buttons right next to the start experiment button, and we select manage test devices. Here we can add test devices to see if your test group or your variant A works properly. The dialog asks for a token. Hovering over this token tooltip will tell you exactly what command to run. So you get something called a token hash. This hash denotes a particular installation. So before, in our example, we ran on our emulator and we saw a blue button, right? So that particular installation has a specific hash. When you run this particular command, you will get a hash back from your code base, and then you basically copy paste that hash, which denotes that that installation should use X variant. In this case, I've added my hash. It's pretty long, so you can't see it. And I selected variant A and saved it. So now, based on this experiment test, my installation should use variant A, even though the default is blue, both in the defaults in the XML file and on the console. We save it, and when we run the app again, we see that the button has turned red. We didn't make any code changes. But now when the app is installed, it's going through our test flow with the button color red. Now that we tested the app is successful, right, and the test group is fine, we can start the experiment. Usually we run experiments for 1 to 2 weeks so that we get meaningful results and meaningful movement in metrics. But obviously this is a test application, and the only time I ran it is when I was debugging it and I was testing it. So there are no real users, and the only events are coming from when I was running the app. But for a real application, we would see results below as a graph, and it shows the total number of events per variant, the comparison between both the 95% confidence comparison between both with 95% confidence intervals, and the p-value denoting the statistical significance of the test. So that's how you can run your own experiments in using Firebase. I hope this session has been useful. Please reach out to me if you have any questions. I am available using the Zoho messaging system, and I wish you all the best for your experiments. Thank you.
Thank you so much, Parth, for this insightful session.
I'll stop sharing now.
Thank you so much. It was really good. Thank you so much. Thanks everyone for attending. We'll go on a break now, and we'll be back by 3:15.